Energetic ion beams are used intensively for the characterization, modification and synthesis of new progressive materials in the Nuclear Physics Institute. The accelerated ions can be useful for a broad spectrum of applications in medicine, ecology and last but not least, in archaeology. For material investigation and characterization, a linear tandem accelerator, Tandetron, is a powerful tool. The acceleration is provided up to several millions of volts. The accelerated ions are guided by a magnetic field into the appropriate working vacuum chamber. Among other applications, one possibility is the determination of trace element content in different materials and structures. Precise knowledge of the trace element is important in many fields and applications. Recently, our scientists studied the mercury content in the hairs and bones from the Danish astronomer Tycho Brahe's remains. We have proven that Tycho Brahe wasn't poisoned by mercury. This experiment was realized using an ion microprobe, which enables us to focus the ion beam spot from usually used several millimeters to several micrometers. The ion microbeam can be used either for the precise elemental mapping or for ion micromachining and nano device construction. An important part of the ion beam analytical methods is based on elastic ion scattering on the nuclei in the various depths of the investigated materials. Such studies showing the elemental depth distribution in artificial material layers, for examples modified by ion implantation, find a broad application in optics, photonics and other relevant fields. Energetic charged particles irradiate astronauts in space or patients under radiation therapy. Thus, a knowledge covering the main processes in living cells undergoing ionizing radiation is of a high importance. For this purpose, living cells are irradiated by ion beams at our Tandetron also. The important task to accomplish is a testing of radiation resistance of various materials and electronic devices. The Tandetron is a small but very useful device, which was delivered in 2006 and gives us an opportunity to use nuclear analytical methods and the ion beams for research both for society and in many scientific and industrial applications.